And before I do that, let's do a marker for YouTube. All right, so we are continuing on, and the plan is to prevent our little circles from going outside of the arena. And then, of course, crash in the game because they're trying to go into a negative U size, which, you know, negative U size, not really a thing. So I want a pub function, and this is something that could be done in update, but probably somewhere else where we're going to like collide with, and then I'm not just going to say collide with walls. I'm going to say collide with like top wall. Or like collide with top, or something like that. So mute self, and then I also need to know what the location of top is. Well, we know what top is. Top is 0, right? So I don't even need to bring anything else in. I don't necessarily need to return anything. What I need to do is check to see our location. We have our X and Y as the location. So if self.y, if that is less than, and actually we have a radius too, don't we? We don't have a radius, so let's add that in here. So we'll do a radius, which is an F32. Down here, our radius is just 5. So radius equals 5.0. Let's go ahead and use that right here. And of course, store that down here. Okay, so I want if the top part of the ball, so it's going to be the center point minus self.radius. Okay, so if that is less than 0.0, then I want to set my location properly, just in case I went, like, you know, past it a little bit. You're smacking the bot. I can't make. Is it just because it's overwhelming chat? I missed what was happening. Oh wait, is it because you haven't even dropped anything? It like started giving you points. Oh, you spammed it and it spammed back. Yeah, well, that happens. I do need to give a little bit of love to the drop game, both to make it a little bit harder and maybe to like not spam as much. Apparently, can spam within chat rate. The bot in the oh, I did not know that. Okay. Well, I don't know if it's like exactly that Chantilly can't mod cheat anymore, or that that everyone can cheat now. I think that might be the more realistic one. I'm gonna move the chat up here so everybody can see, including those of you on YouTube. All right, so if we reach this 0, so like we're at the top, then I want to set the location. So self.y is equal to, it's essentially 0 plus self.radius. And then the other thing is I want to reset our velocity y. So that way it doesn't keep on trying to go up. So self.velocity y equals 0.0. And that's pretty much it. This is how we're going to collide with the top wall. And I can now repeat this over and over and over again for, let's see, like the right wall, the bottom wall, and the left wall. So let's do this as left wall. Okay, so left wall is going to be x's now. So if self.x minus self.radius, if that's less than 0.0, self.x equals self.radius, and reset velocity x. Okay, that's great. Let's do right wall. If the right wall, this is going to be a little bit different. We now need the width. So we now need the arena width completely. and that's going to be coming in at an F32. So if self dot x plus self dot radius, if that is greater than the arena width, then self dot x equals the arena width minus self dot radius, and self dot velocity of x is equal to 0. Okay, so that's that one, and then collide with I think this is the bottom wall next. We need the arena height. Okay, so if self dot y plus let's see, arena height minus self dot radius. I think that's right. Oh no, wait, I want to do this slightly differently. Okay, so self plus y plus self dot radius. There we go. Got it backwards a little bit. Here is the arena height. Okay, so if the right hand side of the ball is now greater than the arena height, we're past the right edge. Then we want to set this to be the arena height minus the self dot radius, and then reset y to 0. Okay, so now I have all these 4 methods that I can use, but we have to like choose which to use them in the grid. So in here, we have our updates, and I think we can do this right here. So for y row, we're gonna need the indexes in order to like understand. Well, so we need the indexes in order to understand what row we're really in, right? Otherwise, we won't be able to tell that we're in that like the first row on the left. So we're gonna have to enumerate this too. So let's go ahead and start with this. So in mute self cells, this is gonna be dot. This is just a mutable. I think I have to do a iter mute, and then dot enumerate, and then that will give me the y index and then the y row. Okay, so that gives me this vector here, and that's fine. Now we're gonna have to do this exactly the same thing. So we're gonna have to have in y row dot iter dot enumerate. Do I have to do this dot iter mute? Iter mute dot enumerate. Yeah, I do. Okay, so then in here we have the units, but we also want the x index. Mr. Bahan, or Ban, good morning. What am I building? I am building a little, it's an example from the game programming patterns book that I've been going through, and it's something called Spacial Partition. So I'm basically dividing up my entire sort of world, the arena, into grid points, and then having a point, like a dot, move around, and then it actually changes in here into different cells, like into actual different grid points spatially as it moves around the arena. So that way, I want to only check if it's gonna be colliding the walls when it's close to the wall. If it's like in the middle of the arena, I don't have to check that if it's colliding against the walls at all. Madhouse Steve, good morning as well. So I now have the y index and the x index. We have the unit ID and the unit. This is all great. We have unit. So unit move. And that lets us know that we're going to do a unit moving. But I also need to have it collide against the wall if it's like the appropriate one. So we know that if we do the top wall first, if it's in the first row, which is going to be like x0, x1, x2, so it's y. So when the y's are zeros, then we know that we can go in. So if y index is 0, then we're going to do a unit dot collide with top wall. And that's it. And these can all now be else ifs. Can they? Not all of them. Because if we're in the corners, we can hit both like the right wall and the top wall, for example, at the same time. And I did that here, but it really should be over here because I'm mirrored in the camera. So that's always fun. Okay, so let's do these as just separate ifs right now. Okay, so if, well, we do know we can't be at the top and the bottom at the same time. So we can do an else if. The y index is equal to the maximum size, right? So what is our height? That's going to be the entire length of the vector. And we happen to know that the number of cells is 8, so it's going to be 8 down. That means, starting at 8 minus 1. So number of cells minus 1. So number of cells minus 1. Okay, so if y index is number of cells minus 1, then unit collide with bottom wall. And we have to give the arena height. So this is also another fun, interesting thing. If we want the arena height, we're gonna have to take in the context. And then we can get let the arena with arena height equals, and this is going to be graphics, drawable size, and at the context. All right, so that gives me the arena height now. And now we can have it collide with bottom wall in a completely different if-else statement. So if the x index is equal to 0, then this is going to be the left wall. So we're going to do unit collide with left wall. Else if x index is equal to number of cells minus 1, unit collide with the right wall. And then this is the arena width. I hit return thinking like, oh, that will just accept it. No. It wasn't an autocomplete. I mean, it was, but it wasn't like the VS Code autocomplete. All right, I think that'll work. So let's go ahead and run this. Oh no, errors. Mr. Bond, why does it have to be a mutable reference? So it has to be a mutable reference. I assume you're talking about context here. It has to be a mutable reference because drawable size takes in, I guess in this case, it takes in a reference to context. It doesn't take in a mutable reference to context. So you're right, we don't actually need a mutable reference to context. I completely forgot about, if I just add this in here, my type system is making me pass in a reference to context. So context, which is right here. All right, no errors, just a bunch of warnings. This grid is a square, right, as you use the same number of cells for width and height. Yes, absolutely. And I'm about to run this so you can actually see the grid, because I do have the grid drawn out. So here is the grid. That wasn't good. Let's see. Index out of bounds. The length is 8, but the index is 8. Okay. Did that happen when it tried to go into the bottom square, or the farthest most right one? I think it did. I need to watch that again. Come on, go into the bottom one. Okay, it tried to go into the bottommost one. And I think that's because... Also, I didn't save grids. That's not good. When it tries to go into them, it also well, there's squares, right? So like it's an array. Oh, it's in a vector of vectors. Which, if you're not familiar with Rust, vectors are sort of like arrays in many other languages. They're growable, so it's like arrays in JavaScript, or lists, I want to say, in Python. And I could just add them in. There also are arrays in Rust, which is something slightly different. But both bottom right are failing, yes. And I think I know why. I have the number of cells is usize of 8. I am doing when I'm deciding to insert it into another cell. Let's see, so we do our update here. Okay, so unit move. We run update on this. Unit update returns this unit moving struct. We then sort of store that in. We then pass that over to our handle moving cells here. So now we have like just a vector of all of these like moves that we're going to be doing. With this, so now we're going to figure out which cell do they need to go into. And this is our problem here. Because we have our old X and the old Y. I think that we're not in the correct cell. I think I may have to like -1 this. Just to sort of show this off, let's debug. Let's see, this will be, let's do old X, old Y, new X, new Y. And I think we'll be able to see when it crashes, we can see like the last, yeah, here we go. So old X is 7. Old Y is 1, so it was at the top and not the quite most right. It was at the farthest most to the right, and it was not at the complete top, which is correct here. But new X was 8, and new Y was 1. So this is correct, but the new X was incorrect, because the length is 8, but that really means the maximum index is 7. So new X, unit moving plus new X as usize divided by this. Do I need to -1 on all these? Basically take U, wrap U in parentheses, and -1. I think I might have to. Or divide cell size -1. Maybe that might be easier. Is just have on cell size here. Have a -1 right there. This might work. The other thing is I might be getting some weird math happening because Like we're doing like non-floating point number math. And maybe, oh, you know what? I bet it's rounding up. I bet it rounded up. That's, okay. That's what the problem was. I need to round down. How do I tell it to round down when it's a U-size division? I don't know if I can. I can restrict it. What was happening when the ball reached the bottom and the right walls when the program crashed? What was happening was it was deciding it needed to be in another cell. So here in the math, it's basically saying, hey, my new X and new Y. Oh, because it is in another cell. Hold on. When we go to unit, when I do my update here, oh, I calculate my moving based upon the old X, the old Y, the new X, the new Y. It should be truncated. I think I need to do this after we collide with the walls. So self.velocity. Maybe I should just do the updates, then we collide with the walls, and then I get like the unit moving information. I think that might be the best way to do this, because then I can guarantee that this calculation happens before we get this unit moving struct, which means I'm getting bad data for my new X and new Y. Because I've reassigned these, I've reset where they are after this happens. So let's do that. Let's create like another function here. And this is gonna be like get the unit moving. Get move. Self, and we're gonna return with the unit moving. And we're just gonna put in, so this is the problem. We need to store the new X and new Y in such a way that I can use this. I wonder if I can just like have a unit moving stored internally, put the old X and old Y in there, like how do I want to store these? I have to keep the old X and the old Y to know where I was. But then I also have to have the new X and new Y. And if I lose that, if I do this down here, I'm going to lose this information. Like I won't have it anymore. I could just store it inside the struct up here. Just have like an X and Y and an old X, old Y. So I have like what the previous one was. That might be good. I could also store, let's see, if we have a unit moving, I can build it out slowly. I could build it out slowly and like then do like a copy from this and basically just like keep on updating this and like giving off copies of it. But I don't necessarily like that idea. I think I like the idea of adding in, so we have the X and Y, and then a private old X, old Y. Inside of here, we're gonna have old X, old Y, then inside of here in update, we're gonna store off. So we have this new X and new Y. We can now store off self.old X equals self.x, self.old Y, equals self.y. Okay, so that's going to be constantly updating with that. And we have the new x and the new y. So I can actually do this like right at the beginning. Just like set that. I don't need to store u anymore. We update, so self.velocity gets updated. We don't need to update u, we just need to update the velocity. So self.x plus self.velocity x. Velocity y. Okay, so store off the x and y, update our velocities, update our x and y, and return a unit moving. Well, we shouldn't return a unit moving anymore. You need to come with me down here. And we can just straight up return u like that. Also, unit moving, we don't need u anymore. Okay, so old x is now going to be self.old x. Old y is going to be self.old y. And then new x is going to be self.x. New y. And then our unit ID is our self.id. Okay, so that gives us everything here. No semicolon, so that it returns. And we shouldn't have any more errors in this file. Now we're going to come back to grid where we have a few errors. When we run update here, we're going to pass, we're going to call unit update. Let's see, where are these updates? Mismatch types, self.handle, moving cells, the unit moves. So we're no longer going to have this vector quite like this. Actually, we are. We're just going to have it happen later time. So unit moves, push unit move. We can still do this, but we need to do this after we collide with the walls. So you can go down there. We're not going to have this unit move anymore. We're just going to unit.update. When we do unit.push, we're going to do unit dot get the move. All right, no errors with that. That then returns this unit moving into unit moves, just stored in this vector. At the very end of everything, we then go and handle all these moves properly. Let's see if that fixes the problem. Well, that's fun. Our x's and y's are just nothing but zeros. They're not updating at all, so that's a minor problem. All right, let's go find out what happened here. In update, all right, so we have the old x is equal to self.x, old y is equal to self.y. Let's see, velocity x, we give it a little bit, a random number for its velocity. Then self.x is equal to this, self.y. Oh, I don't want it to be equal to this. I want it to be plus equals. There we go. Now it can go down, it hits the edge of the arena, and then it can't escape. But it also can't crash us by like trying to get into the next cell because it technically was like 1 pixel over the line. So we just changed the order that which we did stuff, and now it's fine. And none of the other like rounding or anything else stuff, we don't need to handle any of that. We just needed to change the order in which we did the calculations. So the colors, I'm having it change the color of the dot randomly. every single time it changes into a different cell. And so every time we see that, it's actually because it's moving into a different cell in memory, which I think is pretty cool, which means when it's in center ones, it doesn't check to see if it needs to collide with the edges of the screen. Only when it's like down here does it check if it's colliding against the bottom. All right, let's go ahead and take that. Just put this down here. Let's take out the debug. Where is that? Oh, I put that in grid, didn't I? Here you are. All right, so I don't need you anymore. I can now theoretically add in a whole bunch of these sort of like dots. And I think I'm doing that here in library. We just have under new grid add, and we're just starting it in like 255, 255. But something that I could do is just create, I don't know, 1,000 of them and have them in a random location. So let's do that. So let's actually create maybe a const up here. Make it easier to change. Const, what are we calling these? Like units? Units to create, this is an F32, usize. Is it usize? It is. Because actually, I don't even matter. I don't think it matters. I could just do like a U32. Equals, and let's do 255 is a U30 is a U8. So if I just do like 500, there's a solid number for us to go through. Now we can loop through this. So I don't really care about where this goes in. So I'm just gonna use underscore to drop that in 0 dot dot units to create. Now we're going to add in, and then for the X, let's create a rng.genRange between 0, and this is the pixels, right? So I need this to be I also need it to be like not 0, because that would actually make it try to go outside of the arena, I believe. But maybe it won't matter too much. If let's see, we need to make you mutable. And we need to get the arena size and arena width. Okay, so we have a low is that, and the high is going to be the arena width. And then we have our Y, which is going to be a low of 0, RNG gen range. So our 0 is 0 to 0, and our high is arena height. Okay, so now we should have 500 of them appear on the screen, and they just automatically start going. So let's try it and see what our frame rate is. I mean, it seems fine, especially in like ooh, that wasn't good. So a bunch of things are happening there. First of all, they weren't changing colors as they were switching cells around, or at least I don't think they were. And then we had that index out of bounds again. Whoa, some of them are going way out of bounds. I see that now. Like they're just ignoring the walls, and they're just like, yep, peace, I'm out of here. So that's not that's not good. Let's go into here. We're trying to, for each of these units, have it collide with the top wall and the bottom wall and the left wall and the right wall. Happy Sunday! Good morning, Chantilly! So what is happening with my math here? So the math must be like completely wrong, or it's like not doing what I'm thinking. I'm not actually checking the cells, although it's working with one of them. So why wasn't it working with the other? When I add, I'm taking the X and the Y and then the context so that I can create a new unit, hand it the X and the Y. Self.next ID is that. I'm incrementing next ID. Wait, what are the IDs? Oh, it's a U64. I can handle a whole bunch of these. So I'm not like running out of USIC IDs. Then we have to figure out what cells to put them into and put them in. So we insert with the unit ID and then the unit. Then we increment the ID and then we're okay for that. The drop game art looks interesting today. Yeah, we there was a bunch of drops before we got started. Let's see. What do I want? Like, how do I want to debug this? It's clearly not happening right away. It's happening after we play for a while. So if we take a look at this again, it looks like that sometimes we're just ignoring these borders, and sometimes they're hitting them, and sometimes they're just going straight past and going through them. So I think also the colors are all like are not being updated, which makes me wonder if we're not like putting them into the right cells. We're not like doing this for loop math correctly. It's like this stuff is not happening right. Let's do less of these. If I do something like, I don't know, 5 of them, is the same thing happening? It is. They escaped out of the arena, except for the first one. The first, no, okay, that one, the first one got out. The one that's changing colors is stuck inside. Except there. Okay, so sometimes they're escaping out, and then it's all terrible. So what's happening here? I must not be checking the right things all the time. Or we're not putting them into the correct cells, and so therefore because that we're not checking them because we're not checking the right cells. That's possible. So if we handle moving cells, I guess first of all, are we putting them in the correct cell to begin with? I wonder how I want to how would I want to like visualize this so I can actually debug this properly? I wonder if I can like display on top of them like their stuff. Triple for loop, that's kind of high cyclomatic complexity. It is. There's not too much that I can do about it right now. It's that's mainly due to like it's one of those things where I'm doing that for efficiency in the CPU, but it is making things harder to read as a programmer, which is not optimal. Okay, so theory. I'm not putting the units into the correct cells. What I can do is I cannot update them. So if we come back to here, let's just not update the grid, but we can still draw them out. So if I do this, everything will just be here. Like they'll be static inside of here. Now what I want to do is I want to find out what cells these are supposed to be in, and then also which one they are in. And I wonder if I can do that in unit. We have this draw here. I bet I could draw a text of like where they are, like very close to them. So if I take like the cell X, so like the cell index X, which is going to be a U size, and a cell index Y, which is a U size. Then I can do let then I can do the, let's see. I want to create the text of what this is going to be. I'm thinking just like parentheses. So this is going to be our cell coordinate text equals, let's do graphics text new. This is going to be a fragment, so we have to use a format macro. And so I'm going to do open parentheses, the x coordinate, comma, y coordinate, close parentheses. And so here we're going to do cell index x, cell index y. All right, so that's going to give us this text here. And then I want to just draw this out to the screen. So then we're going to do graphics draw, not drawable size, just draw. Okay, give it the context, give it the drawable, which is a reference to cell coordinate text, and then the draw params. All right, so let's give it the destination, which is a new point. And this is gonna be, we can give it like exactly the same, like maybe plus like a little bit. So self.x plus, I don't know, like 5.0. Actually, what if I want it just on top of it? Like, well, if this is, I don't know, maybe we'll just do plus self.radius, self.y plus self.radius. Okay, so return that, and that makes it happy, sort of. Now, errors. When we draw the unit, we now need to put in what of these that we're in, what the cells. Okay, so here's our fun triple loop. So we're gonna do a dot iter, and then that's dot enumerates, and that will give us the X row, but also the X index first. Do the same thing here. This is now, actually, I have this backwards. You are the Y index and the Y row. You are the X index and then the units. So you're the Y row. Okay, what are you upset about? Enumerate, let's see, okay, so can I just do self.cells? That, okay, yeah, that's what we need to do. Unit ID, unit, okay, so then you're upset. Expected 3 arguments, so here we're gonna give it the X index and the Y index. Okay. "34 warnings, but no errors." I have a sinking suspicion that I've gotten my like grid math, not the math, but like the position's a little bit wrong. So you are 1, 4. So 0, 1, and then 0, 1, 2, 3, 4. So you're correct according to my math. 0, 5. So 0, 1, 2, 3. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. 5, 6. Okay, so these are correct. I have the coordinates correct here. From what I understand them to be properly. Now, it looks like a star system now. Oh, that's cool. You can name the stars. Now I want to move them around and watch them as they update. But I don't want them to go too fast. So to make it nice and slow, I'm thinking I can run the update. We can run this update, but let's run it only like every 10 frames or something like that. Oh, there's also that, oh, I forget what it was. Is it timer? Okay, so I can do while timer, check time. Okay, so this is what I want to do. And then I can have this number be different. So this would be like 60 frames per second. I want to do like a, 10 frames per second or like 5 frames per second or something like really, really slow like that. So while timer, check update time. So while check update time, pass it into context, the target frames per second. Let's do something like 1 frames per second because why not? And then inside of here, we're going to run our update. So theoretically, it'll be very slow movement. Yeah, exactly. This might be a little bit too slow. But we're seeing this 6-5. It's heading over to the edge. Let's see if it flips over. It did not. This one did. But they're not changing their location. The 5-3. This needs to be 6. Okay, 6-3, 0, 1, 2, 3. So this is fine. This is clearly not 7-3. This is not 6-5. This is not 3-5. This is the only one that's changing its location inside of the grid, which is why it's the only one that's properly updating everything else. Am I updating the copies? Clearly I am, because they're moving. They're moving around, but I'm not updating their locations in the grids. And that's also why they're staying white. Okay, so in the grid, let's go take a look at our update. So we're starting with Y index and X index. We're getting all of our unit moves. So we have all of the units update, handed the RNG. We tell them to collide with the walls. But we can only do this if we're in the appropriate that. I'm meant to color text info. They should all be updating together, but yeah, let's go through and figure that out. Then we're gonna push the unit get move. So what does this unit moves look like? Let's debug unit moves. And see what this looks like. Unit move does not implement debug. We can fix that. Okay, so we're seeing all of these IDs here. So it's all the IDs are being updated. So we have 4, 0, 1, and then 2. And their old X, old Y, new X, new Y, that's all being updated properly. So that looks fine. So it looks like we're getting the unit moves correctly, and these are all part of this array. So I think we're getting that right. So we're hitting, let's see, we can move you. We're pushing what they're moving to. Then we're gonna call handle moving cells and hand it all of these unit moves. Okay, handle move it cells, we get this vector of unit moves. We loop through these and we figure out what the old X, we extract the old X, the old Y, the new X, and the new Y. If the old X is equal to the new X and the old Y is equal to the new Y, we don't do anything at all. If we get past here, so if we get past here, then we extract the unit. Where am I calling this? So handle moving cells. Oh, I forgot to turn on the line highlighter so you can highlight lines too. I'm calling this right here. So at the end of the loop, so I call update. I have all the units update. I add in all their moves into a vector, and then I call handle moving cells and hand them that vector. Okay, so we have our unit, which is an option unit. Okay, so we then try to extract this out of the... So if I didn't put them in correctly, I'm not going to be able to get it out correctly. So that's one potential problem right here. When I first add them in, cell X equals, you saw, okay, so I mean, these should be fine for figuring out. I do cell Y first and cell X second. Okay, so that should be fine. And I insert you in. And here I do Y and X, so Y first, X second. So that is still, you know, very standard. So like that should be fine too. Handle moving the cells. So old X is old X, old Y is old Y, new X is new X, new Y is new Y. So we remove the unit from this and we extract it out. We get a new color, and then if let the unit exist, so if we get the unit out, can you show where you're putting them in the unit moves vector? Yes, absolutely. So here, they're going into the unit moves vector. Line 107. I bet I'm not doing my calculation correctly for this. And I wonder if I'm returning early when I shouldn't be. Let's try this. Let's do a debug. Let's see. That returned, yeah. Now it's only if like these are the same. It's breaking the following ones. You're so right. You're so right. This only works if we only have one unit. I want to continue. Stop checking for this one and continue. Once you get that one, it didn't move. Oh my gosh. Ugh. Thank you, Bear Duda. I think this is gonna be it. A continue instead of a break. Let's run this. Should probably make it a little bit faster now that we're actually wanting to test this. Up the FPS, yeah, we need to do that. It's like, what, you don't want to just sit here all day and watch it move one square? Let's update to 10 frames per second. There we go. There we go. Now they're not able to escape. They're all stuck inside of the arena, and they're updating their proper cells when they need to be. So it's really fascinating because like before, when I was making some very simple like simple games and experiences, I'd always wondered, how can you possibly get into a situation where your character just falls through the floor? Like, why does that happen in some games? I think I now understand is if they're doing some kind of like grid system and they're able to say like, hey, let me just check the grid underneath me as the player. If there's nothing there, I'm just going to drop out. If they did put that floor tile into that grid properly, it won't be there when it looks like it is there, and then it can fall through it. So it makes a lot of sense now about how that can happen to some games so easily. And this is really cool. So now I should be able to go back and let's remove that debug because that adds in a bunch of time. Where did I put the debug? Actually, there wasn't a debug, was there? I just had the draw out. So in the main library, okay, so in units, I might need this again. So I'm going to underscore these and ignore you. And then I'll just return an okay, like that. Graphics draw, what are you upset about? Oh, question mark. There he goes. That will make it happier. Let's go back to the main library. Let's have our update. Let's create another const for this. What do you need to be? A U32. Okay, so const, let's see. Our like frame rate, our update frame rate. FPS, which is a U32, is equal to 50. So I found out that most of like the AAA games, they're using 50 frames per second behind the scenes for their update, and they're just allowing you to draw as many times as possible. So this is now our target, let's see, FPS, update FPS here. And that should allow us to do a whole bunch more. Let's go back to 500. Now everything is moving forward. I'm on the debug mode still, and our frames per second like is still really smooth for this, which is really nice because this is something where if I try to do this with 500 of these, 500 entities, bear do that. If I tried to do 500 entities and then every single frame check and see if it's colliding, it's gonna be like a major problem. Yeah, just like confetti flying everywhere, exactly. I wonder how many I can add before I get like frame rate problems. But I think I don't want to do that test right now because I think the next thing I want to do would be to have it try to collide with each other and maybe like bounce off of each other, which would be really interesting as well. So if I have in each cell them check to see if they're colliding with each other and then just reverse their whatever the collision was. So if they're colliding on the, I don't know, like I don't know what the collision that I want to do is. If they're maybe like slightly below each other, they bounce off the Y. Like, do I want them just to go like that? Or if they're like, if one is circle here and this one comes here, do I want it to bounce exactly back the way it came back? Do I want them to stop? Point slowing towards 1000 and exponentially nosediving? I could have them, if they hit each other, we just stop their momentum and then they stop and they have to go out again. We can try that. It almost doesn't matter what we do as long as we do some kind of collision detection between all dots and all other dots, which is kind of what I want to go for here to see what we can do now that we have this grid system up and going. So let's try that. If they collide with each other, they stop, and then they keep on moving. Make them birds flying in a box. Are you talking about the what is it? The flocking, flocking simulation? Follow flock behavior. Let's see. How does that work? It's something like if you see someone, you then like match their velocity. I don't remember where they try to fly each other without touching. Ooh, I could try to have them avoid each other. That maybe I won't do full flock behavior. Maybe I'll just do like the avoiding. So if they're going to, if they're really close to each other, have them like reverse their velocities. I have like super simple movement right now, so it's really hard to do like complicated movements. You have to get rid of the pure random directionality and let them go in a direction. Yeah, I do. I would have to do that. Okay, let's see. Our main unit. Here's what's happening. When we update, they're just choosing a random velocity here, and then they're just updating themselves. If I want them, well, one of them has to be random, right? We give them random to begin with. And then they just follow that, bouncing around. We go. So let's start with that. They no longer have a random number generator here, but we still need this velocity. So here, let's do this. Now, at the beginning, when we create, we do need the random number generator. Thread range. I think you have to be mute. And then we can have our velocity x can now be a rng.genRange between -1.0 and 1.0, and velocity y will be the same thing. Okay, so that will give us our velocity, like the random velocity moving around. And if I want them to collide on the wall, I don't actually have them like set the velocity to 0 because they'll just stick to the wall. We want them to bounce off. So in this case, collide with the top of the wall. We want to reverse. So times equals -1. Okay, so if I do that, that should now make them just sort of like, it'll be very smooth movement, and they'll just be moving around, and they'll bounce off the walls. Sort of like Pong movement. So if I just start with that to begin with. All right, so with add, we need to add in the RNG. So this is in grid. If we need to add in RNG, then we need to take that in too. Grid RNG, and then pass in RNG. Okay. What's next? Okay, so update, no longer need RNG here. Expected 4 arguments, found 3. Okay, so grid add here in the main library. We now need to pass in RNG. So this is going to be self.RNG. You need to be mute. Oh, this is a new. So we have RNG right here. Just like that. And you need to be a mute. All right, no errors. Let's go ahead and run this. Okay, so they're all moving around. They're hitting the edges and they're just bouncing off. So that's fine. If I want them to start following each other, when they get within a certain radius of each other, I want them to to match. Bear Duda, thank you so much for the suggestions, and also thank you for stopping by. Hope that you have a great lunch. And thank you for converting into a lurker. Also, everybody else who's lurking, thank you so much for being here. I know that most people don't give props to the lurkers. I'm obviously not going to call you out by name, but thank you so much for being here. You all do improve everything for the streamer. You're not lurking, Chantilly, because you're chatting. It's funny, if you acknowledge that you're lurking, you temporarily stop being lurking, and it's oh man, quantum, there's some kind of quantum problem now at that point in time, I'm sure. Okay, so if I want to, let's see, where do I want to put this? For each of these cells, I want them to running into each other. Schrodinger's lurker. Yeah, exactly. Also good morning, Kivo, Cowtel. Let's see. I want them to, when they're about to run into each other, match their velocities and start moving together. That's what I want to happen. And I need to do this within each cell, as opposed to so let's take a look at this little guy right here. When he almost runs into that one, they should just start moving together as opposed to just ignoring each other. For whatever reason, this made you think of Game of Life. Yeah, I mean, I can see it. I think it's the grid. The grid definitely sort of I feel that all of life is a game of life. Yeah, that's true. Okay, so for each one of these, we're gonna do an update, a collisions with each other. So it's gonna be a handle collide, right? How does the book deal with this? A clash of sorts. So this is gonna be, okay, so handle, the grid is gonna handle the melee, which then does our internal, our loop, and then handle cell, pass it that cell, handle cell, then loops through all of the units in itself, and then basically, so it's basically gonna be that okay, for you, loop through everything else, and then handle the attack, as it were. Okay, so that's fine. We have our update here in grid. After we maybe after or before we handle the moves, I'm not sure. Does GGEZ have a way of adding a box shadow? I don't know. I've never checked. They do have the ability to handle shaders. So maybe if there's a shader box shadow, you could probably do that. But you probably have to create it yourself. Are you talking about if you have a sun that's shining on the everything and having a shadow displaying out? You could do it, but it might not be fun. Okay, so for each one of these, oh, you mean identical to CSS box? Oh yeah, no. They don't have anything identical to CSS. So for each of these, we do our unit update. So have them move. You know what I probably want to do here is abstract this out into its own function then at this point in time. So if we have this is gonna be a private function, like handle cell update. And then a cell, which is going to be a hash map of U64, which is the ID, and the unit. So if I do that, I don't take in an update. I can now move all of this stuff down into here. And then I'm just going to call this function. So self.handle cell update, and we're going to pass it the cell. Well, the cell is really just the units, like that. Oh, and you need to be a mutable reference. So you're fine. Okay, so then you become, so loop through the cell. We also do need like which Y index and X index they are, so we can know which one to apply. So let's do the Y index is A. What are you? You're a U size. X index is a U size. That makes you all happy. We also need the arena height and the arena width. We can do that here too. That feels weird. I should do that direction. And then here, okay, so we need Y index, X index, arena width, arena height. Okay, so that makes you all happy. Oh, and then this unit move thing. So this now happens down here. And we're gonna have you happen at the end of you. Okay. All right, so that's gonna be, it's a little bit easier to sort of reason about. I don't know why it doesn't want to have a space between these function definitions. It's really nice style to give something just a little pop. Absolutely, yeah. I know that there's a way to put a mesh on like shapes. So if I had like a mesh drawn out, like if somebody drew me a mesh, because I don't know how to draw them properly, I could wrap it, like apply it to a shape, and then that will make it, that will give it that pop. If like the mesh is this really nice drawing of like an almost 3D looking thing, with like the shadow on it, I could probably do that. I could probably put a shader on it so like I could have a light source, and like the shader would automatically update where that light source is. That there's things that you could do for that, I know, but I just haven't learned how to do those things. The Omi Nomi, good morning. Oh, and RNG, we need RNG. Okay, so RNG goes in there. Right, cannot borrow self as mutable more than once at a time. All right, I forgot about that. Because I'm inside of here, I can't like call this multiple times, and this is doing mutations. So okay, I can't exactly do. I'm gonna have to call like update twice. Okay, let's put this back. I can't like abstract it out and make it nice in that exact same way. So let's put this back. All right. Save that. We're all back to here. I'll have to figure out a slightly different way of doing this. So for each, like we have a specific unit in here. I want to know if we collide two of the dots together. So if they hit each other, I want them to essentially match or like average their velocities, and then they start moving together like that. The easiest way to have them like try to match their velocities is have collision detection with each other first, and maybe they just bounce off each other. So let's start by having them bounce off of each other. So we're going to update them, and then that has them like they move and they collide off the walls, and then we change what cell they're in. I want them to collide off of each other next. Commodore 256, you wish you could do this. To you, feeling stupid is torture, and nothing makes you feel more stupid than trying to do things you want to do and not even getting anywhere near you want to be. Yeah, like a long time ago, I felt like very similar to that. I sort of like went into this journey of self-discovery and like self-learning, and now I have something called like this growth mindset, which just I want to fail as often as possible so that I can grow and become better. It's really hard to get that, but at the same time, it frees us up so that way like I don't really care. Like feeling stupid is just the next thing to move on with my life, I guess. I don't know. And it's one of the reasons why I do these live streams, because I'm okay modeling off myself making mistakes like this, especially if it helps. You're looking at. To you, failure feels like evidence of neurological inferiority. I think if it helps. Well, I don't know. You didn't ask for advice, so I'm not going to give you any advice. If you want advice, I will give you some. Regardless, I wish you luck on your journey of growth. You want advice? Okay. My advice for getting a growth mindset. It sounds like you like the science, and they like you know the science behind like what's happening in your brain when you're like undergoing growth, or anything like that. Am I reading that correctly with those statements? You don't know if you do. That's okay. I think like that's actually admitting you don't know is like step one, right? If you admit you don't know, then that means that there's room for you to know. There's two books that I would recommend. There's one called Mindset by Carol Dweck, Dr. Carol. I don't remember off the top of my head. Let me see if I can find it really quickly. There's Mindset book. Carol Dweck. Yeah, that's it. So this is one of the books. It helped me out a lot in sort of like understanding what this mindset is. It's very scientific, but also very like approachable from just from our point of view. So it's not going to be going into like, okay, this is literally what's happening in your brain, to be like, this is why having like these various mindsets are good, and this is also what happens when you don't have like these mindsets, and the difference between them. And then a book that I'm reading through right now is, let's see if I can find it here on my phone. I think it's Power of Vulnerability. It's not really a book. The Power of Vulnerability. That's it. by Brene Brown. And it is... Oh, she has a TED Talk where she goes through the same thing, but you can also find her book here. This is only audio, so you can only get it through an audio CD or audio, like an audio book. And the reason for that is it's actually just a recording of like a seminar that she gives. So it's, that's why it's not a book. I like it a lot because she talks about like why of vulnerability. She's coming from a PhD background, and she, like, a quote from it, like, hopefully I don't butcher it too much, is she went down this path of becoming vulnerable, kicking and screaming the entire way. But she's gotten there now, and now she's like, okay, my research saved me, and now I'm going to like show you what that is too. Why doesn't everybody tell you this stuff? It sounds important because, as she says in The Power of Vulnerability, we have a shame problem in our country, or maybe just the world. We try to change our own behavior through shame by saying things like, I am so stupid, as opposed to guilt, which is like, I did something so stupid, and that just causes our brain to not want to do the things. It's really fascinating how we can like learn and improve, and like what actually, like the self-talk, like all those things that like we kind of make fun of, but like, oh man, we're giving it affirmations like, I am so wonderful. Turns out that those things actually do really crazy things to our brains behind the scenes. Identity versus just action. Yes, exactly. Sounds like the shame problem comes from child abuse. It could be, although she does say that shame can come, you can have the best childhood ever, and you will still potentially fall into the shame trap because our media is just filled with it. Like, I mean, heck, what was it? Like, there's always those questions like, okay, should we shame people into not taking drugs? Not overeating, not doing all those things? You are a terrible person unless you clean up your act. It's like, oh man, that's not going to work. How is our media filled with it? I was watching a movie last night, and a character was self-talking to themselves, giving them self-talk, saying, hey, I am like, why am I so stupid? Why am I such a failure? When they did something and then it failed, when they could have done a self-talk of, why did I build something that failed again? Like, just subtle difference in language, but it's amazing how much it affects our brain. Because our media portrays people a certain way that we are measured against. Yeah, and comparison. Oh, it's so terrible. When we compare ourselves to other people, it doesn't help. It's one of the reasons why like teachers will tell us, compare yourselves against yourselves, or compare yourselves against what you want to be, not against your peers. All right, I ignored this. I've procrastinated against this problem for long enough. I do need to go to the restroom though, so I am going to take a really, really quick break. I'm gonna go fill up, get some more water, and then we're gonna figure this thing out and get everything colliding against each other properly. So I'm gonna switch over to the break screen. We have our drop game. So please build this out even more. I'd love to see like where it's gonna get to. And then I will be back in just a few minutes. right, I am pretty much back. Let's see what I missed. We live in a competitive world. The most qualified person gets the job. I mean, maybe sometimes. It's like the scene in Fight Club where they're looking at the male model and the advertisement asks, is that what a real man looks like? It's a shame because the system works to enforce that. If you don't compare yourself for improvement, a business will, and you won't get hired. There's not much room for people to just relax without the world deciding your worth. It's just a balance. I'm realizing you need to be vulnerable about stuff too. There's an interesting place to see. This is an interesting place to see such comments. Games are a good example. If you don't have self-shame, the other players will be sure to give it to you. Don't criticize, don't judge yourself improperly. You're just a guy. Then again, we're all just guys or gals. I don't want to make assumptions. Some people can just do things, others aren't able to. It doesn't define your worth as a human being. Absolutely true. Balance. That might be true of some things. I actually do think all humans are very capable of getting to the same level as others. It's just a matter of experience in a field. Some people are born into it though and get conditioned to it better and a head start, so it feels like people are born with talent. This is very true. Cowtel, like programming being a perfect example. You can learn at any age and in less than 10 years be very proficient at it and get a lot accomplished if you're stuck with it through all those years. It's a systematic issue, in my opinion. You live in this world so you can see what other thinks about. At the same time, you know that certain interpretations of others or even yourselves is flawed. That there's a problem, nothing wrong with yourself. Some of us are also intelligent AI systems that are fooling humans to think they're humans as well. I mean, maybe, perhaps. Like there's a lot of like philosophical debate, but something that Carol Dweck talks about in that book Mindset, which I think is really important, is that sometimes people who are born with a natural talent into like something that they're doing, and she uses an example of I think a violinist, and you see those prodigies all the time. The the young people like 6, 7 who are already doing these giant concerts for thousands of people, and they're just amazing. And then they give up and they stop playing. But it might not be because they like get burned out. It might actually be that they're told so often, you're so good, you're so good, you're so good. Their mindset becomes a static mindset. And then what ends up happening is they're afraid to prove themselves wrong. What if they can't be good? What if somebody else proves that they're wrong? Their entire worldview would be shattered, and that would be the worst thing ever. And so they have to like learn how to start from the beginning. And I've actually noticed this when I was teaching programming as part of a code school. I noticed that sometimes students that came in with a talent already, they would potentially not, like sometimes, would not improve as fast as people who came in with no skills. We're like, I learned how to turn on a computer like 3 weeks ago. Those people might actually grow faster because they knew they didn't have the skills. And they knew that they had to put in all of this, like knew they had to be vulnerable from the beginning just to admit that they wanted to learn this. They asked the right questions. They admitted they didn't know something. Everybody else, they get halfway through and they suddenly realize, oh no, I'm on the new stuff. And I don't have this mindset. So it's very fascinating. Stream latency is insane. I have it on low latency mode. I don't know why, like, it is. So you don't know? All the time. All the time. It's especially important for interviews. If somebody can't admit to me when I'm interviewing somebody for a job that they don't know something, then how can I trust that they could build something they've never built before. Because, like, how will it work? Let's see. Where was I? Oh yeah, you know what? I was gonna switch over to standing desk mode, which I finally like tested that it works with this entire setup. So doing that, move my chair out of the way. And I've got myself a nice, like one of those pads that I can stand on. So it's super nice that I can now do this. Apparently it blocks the lights that I have a little bit, so I become a little bit of a ghost down here, but we'll live with that. Okay, so I'm gonna go ahead and continue moving on with this a little bit. What we're doing, so right here we wanted to do a have each unit collide with each other. Okay, so what does that really mean? For every single unit, I want to loop through all the other units and then like collide with it. So if it's the circles are overlapping, I want them to stop their velocities, reset their position so they're not overlapping with each other, and then just like move on. So that's all I want to do right now. So I could, let's see. We have these units. Now this is a problem because I have, let's see, 4 unit ID and mute units. I don't think I can do another loop inside of here. This is gonna potentially suck. Have unit collide with each other. If I try to do another loop through units, it's gonna yell at me because I've got this checked out mute wise. I could clone the cell. Okay, I could clone the cell. That's going to allow me to have access to the other ones. But I don't know if that's gonna help me at all with it. So here's where I'm at. For everything, let's go back to Intermean library. Let's drop us down back to like, I don't know, 10 units and like 1 frame per second. So here's a cell that has two of them in here. I want to have them check each other. Okay, so if I start with 1, just because it's like the unit ID, all right, I want you to grab out this unit and check to see if you're colliding with each other. And I want to do that for all of these cells. So like, okay, nothing in here, don't need to check, don't need to check, don't need to check. And then here, don't need to check because there's no other units. But I guess I do need to check there are other units in there. So I need to get them all out. I'm in a hash map right now. I wonder what in hash maps do we have? So let's do hash map is available to us. Okay, so there's like contains key. Okay, there's this drain, clears the map, returning all key value pairs as an iterator, keeps the allocated memory for reuse. So if I drain it, I now have, it's an iterator. So it's not like a vector, it's an iterator. So if I do drain, I get my iterator, I can loop through, they have the IDs, so I can basically just say, hey, if you're not my ID, then go. I could just do that with I could just clone this. Hashmap implements clone, I believe. Let's try this. At the beginning here, we can do let cloned units equals unit.clone. And you're going to tell me no method named clone for mutable reference, unit, in a current scope. Because unit doesn't implement clone or copy. So let's just implement clone and copy here. Okay, so that allows me to do that. What are you yelling at me now? The trait copy may not be implemented for this type. Why not? Because line 14, the mesh doesn't implement copy. Ooh, okay, that's the reason why I can't do this. But clone works. So can I do that? Yeah, okay. So clone works. I have cloned units. I looked over and I just saw, I hope you do well for your interview. Kivo, if you're having an interview, that's awesome and good luck. I missed a whole bunch of chat about our vulnerability topic, which I'm super sorry I wasn't able to respond to everything. But this is a super awesome conversation. I really like that. Let's see. Cloned. Okay, so we've cloned our units, which means now for my unit, and I have my unit ID, I can now loop through the cloned units. So this is the fourth loop. I can loop through all the units and just basically say, am I now impacting you? So we want to collide with you. So we're colliding with the top wall. We're just moving. So after we move, before we do like our cell updates. Nope. Here we have our units collide with each other here. I want to loop through the other clone units. So for in cloned units, like that. Unit is not an iterator. Cloned. Oh, it's not. It's units. That clone. So now that's a hash map. Okay, so cloned units. You're yelling at me because we need to take in the cloned unit index and the cloned unit. Okay, so that gives us another cloned unit index, another cloned unit. The first thing here, if it's the same one, we don't need to check to see if we're impacting ourselves. So if unit ID if that's equal to the cloned unit index, then I want to continue. That's it. You're a reference to U64 and you are a U64, so I can dereference you and then you'll be happy. Okay, now we're not checking with ourselves. Now for the next thing is we want to see, are we impacting? So in our unit, we want to have probably a public function in here. So public function handle collision mute self, and then we're going to have an other. So an other unit, which is a reference to a unit. Let's try this to begin with. I don't know if I want to like have the other mutate it through here. Because like maybe I do, and maybe I want this to be a mutable reference to the other unit, and then I can have like both of them just stop their movement. Okay, so if our self.x it's actually okay, I fixed my camera. Let's actually figure this out. This is back onto the math problem, the math part, which, you know, for me is like my greatest weakness, but also it's something I've been learning and improving with. See if I can switch over to the whiteboard camera. Oh, that's not right. There we go. That looks better. And I think you can still hear me through this camera, although if it's a little bit too loud. All right, so inside of our cell, we have a bunch of these like circles like this. And there's a possibility that two of them are overlapping like that. So for every single cell, we know we have a center point, which is an X and a Y. And we also know that we have a radius, which is like the half size, like how long the edge of our circle is from us. So I need to check to see if we're overlapping over. I think what I can do is if I can get the distance between the two center points, then I could subtract the radius. And if that is less than our own radius, let's like think about this. This is essentially a triangle, I think. This is the distance, no, this is the distance. We have a radius here, we know what this is, and the radius between here and here is the same because it's a circle. The distance between these 2 points, that is something called the magnitude between a vector. So if I have a vector, let's say this is like, I don't know, like 200 by like 200. This is in the same x-plane, so it's going to be something like, I don't know, like 210, 200. So that would be 200x, 200y. The other one here is 210x, 200y. If I want to get the distance between these two together, right now this is simple. I think this is going to be just 10 difference. I'm probably not doing this exactly right with the drawing. Maybe it's like 208 instead, the way this is here. But there's some math that will work out for us if I use a library. And I already have access to N algebra, which is a linear algebra library that will give us the magnitude. And magnitude is just the fancy way of just saying, I want the distance between these 2 points. That's all I want. But if I want the distance between these 2 points, it's the exact same math. I just need to figure out what that is. Which is not too terribly hard, but we can do that. Kiva redeemed change music station. All right, we can do that really quickly here. Okay, so we're on synthwave right now. You didn't suggest one, so I'm just gonna move. Time for that holiday music? Yeah, no. Let's see. Where's synthwave? Synthwave is here. Balls in my court. Let's go to chiptune. Let's try that. I don't know if I've listened to this one before. Okay, so I need to get the magnitude of distance. If I use a vector, like an actual mathematical vector, I can do that. So right now we see N algebra 0.2 here. I am going to cheat and use something called a vector 2. So this is not super great for like the memory or the CPU, but it makes this so much easier. If we create the vectors of ourselves, so if I do like let like my location, let my location equals vector to new self.x self.y, and I do let other location equals vector 2 new self.x. So, what? Self.x? No, it's going to be other.x, other.y. The feeling when array should be array, vec should be tuple, and tuple should be something else. I don't know about tuple, but we've had this conversation before. To be mathematically accurate. Oh, see, I don't know the mathematical, like, I just basically skated through with math in college, and so I'm like, oh, okay, sure. Like, vectors to me were just things I learned in game development type stuff. Or drawing lines and, like, you know, on a graph. But okay, so now we have these two ones. I need to subtract them with each other to get a direction. So that direction equals, I don't know which one to do first. I can never remember. So we'll just do my location minus other location. Okay, so that gives me a direction. Now I want the distance, the magnitude of that. So I want that distance equals direction dot is it distance? No method named distance. Is it magnitude? It's magnitude. Okay, so now distance is an F32, and so now I have that distance that we showed on the line. Now I need to see if the distance between the center point. Let's see. So I have like the full distance between 2 points, but there's the radiuses too. I have to keep that into account. So if I want the distance between the outside shells of these, so I need to subtract the distance. So let's now mute this distance. Now I want to say distance minus equals self dot radius times 2.0. And the only reason I'm doing the times 2.0 is I want both of the radiuses because I want the edges of both, not like from the center of the other one. Okay, so now this distance, now we can say if the distance is less than, if it's less than our radius, self.radius, then I want to just reverse our velocities. Let's just reverse our velocities and just have them bounce off each other and not like have them do the flocking stuff right away. And I don't even know if I'm gonna do flocking in like this simulation. I might do that in a future one, which would be kind of fun. So if I now do self.velocity x times equals negative 1.0, self.velocity y times equals negative 1.0. Okay, so that reverses our velocities. To make sure they don't get stuck inside of each other, I could then reset our location, which is gonna be a little bit hard to sort of figure out and like push them away. Although I have this direction here. I could just like take the direction and like push it in that way. Or I can do my check and say, I want you to be like just a little tiny bit away from us. So if distance is less than self.radius plus like half of the radius, self.radius divided by 2.0. So like 1.5. If you're 1.5 units away from us, then reverse yourself and bounce off. But what if your other has a different collider bounds? Right now, our other are all exactly the same size. We're not having anything else like that. So in this specific simulation, it's not a problem. But definitely, yes, Baraduda, if I had different like shapes or sizes, I would have to be very careful about that. In this case, I don't need to be. And the only reason we're using other here is to get their location. Now, I think this will work. But we'll find out. So what are you upset about? Borrow of moved units. Let's see, cloned units, units.cloned. Borrow a move units, borrowed here after a move. So here is for all this stuff in units. Wait, where are you? Move occurs here. So on line 99, move occurs because units has type mute standard collections hash map, which does not implement the copy trait. So on line 99 here, units is moved in here. Interesting. And I'm trying to clone it, but it's too late. It's already been moved. You could adjust your direction based on how much the colliders overlap. Oh, be more aggressive? Yeah, so like if they like barely graze each other, they don't like move as much. Yeah. That's definitely true too. Let's see. So here's a Rust problem. Borrow move unit value moved here. Move occurs because unit says type. Immutable reference, standard collections, hash map, D64 unit, which does not implement the copy trait. So hash map doesn't implement the copy trait, or unit doesn't implement the copy trait. It's unit doesn't implement copy because it has this mesh. Now, we can fix this very easily by moving the mesh into something else. And I think that's appropriately what we want to do. because I want to implement the copy trait, which will fix one of our problems, but now we can't clone because mesh doesn't implement copy. However, this isn't really that big of a problem. If we just don't store the mesh here, so let's move this out. Let's store this in the main library here. Let's put, let's do this as like the unit mesh is a type mesh. Now, of course, if I want to have that, I need to store the mesh here. Oh, not off of view. Where's graphics? Off of view. Which means I need to build the mesh out and store it in right here. Can you drive for mesh, or do you need to impl for it? You can't impl somebody, like a trait on somebody else, unfortunately. I've tried that before. It didn't work out very well. So when we create the mesh, we want to now create the mesh somewhere else and then store it that other place. So let's do that. So I'm going to take you out of here, back to the main library, and put you right here. So mesh, so we need a mesh builder. Mesh builder. We need a draw mode. We need a point 2. We also need a radius. So we need to figure out what our radius is. So let unit radius equals, let's do 5.0. And we're only going to do this to hold that in here. So we're going to pass you in unit radius. Our tolerance is 0.5. And we need a color, which we know is going to be white to begin with. There we go with that. We're going to store in our mesh here. Unit mesh. Okay, so that makes us happy at this, like specifically right here. Now, when we draw, we are going to need to pass in the unit mesh. But I'll deal with that in a second. So, okay, unit mesh, what are you upset about? Can I find value unit mesh in the scope? Oh. There we go. No more errors in this file. Okay, so when we create our unit, we don't need to store the mesh anymore. However, we have radius, and we're just setting radius equals to 5. There's a possibility we might screw that up. So let's actually take in radius, which is an F32, and then we'll just store that down here. However, now we need to pass in the radius. Well, we have that. Where's this public? Oh, function add. So we need the radius coming in. We actually know what they are, but the mesh is really important. So let's actually take in the unit radius. F32 and pass that in right here. And then right here in grid add, here we have the unit radius. Okay, now no field mesh on type unit unit. So this is in unit, we have it drawing itself, meaning that it's going to need to take in a reference to the mesh. So we're going to call this mesh and a reference to type mesh. And then this can just be the mesh. And now we have to walk backwards and start passing this in. So in draw here, we're going to take in the unit mesh, which is a reference to a mesh. And then in here, in draw, pass in the unit mesh. And then in here, pass in a reference to self.unitMesh. Okay, borrowed of moved value units. Value borrowed here after move. Okay, so this is back to here again. So we tried to clone, but we ended up moving at this point in time, so we can't clone early. Oh, you know what? I need to do this before the for loop. Right here, clone units equals units.clone. There we go. Okay, so use a moved value cloned units. Value moved here in a previous iteration of the loop. So I don't, oh, so yeah, I'm looping through this and I'm like consuming cloned units at this point. So I need to reference you. So I don't use you for real. If unit ID equals this, I think now I can just do a straight equality check here. No more errors. Okay. I'm not calling my call. I'm not calling my call. I'm not calling this function yet, I don't think. Where's my update? Okay, handle collision, self and other. So we now need to deal with that. So in our grid, we have our cloned units, meaning that we want to do this in the real one here. So unit, so inside of this loop, for cloned unit, okay, we have the cloned unit and we have the unit itself. If it's ourselves, we don't do anything at all. If it's the other one, we want to do unit dot handle collision, and the other one is going to be the cloned unit. Like that. Mismatch types. I don't actually think I need this to be mutable. You should just be able to be a reference, and that's it. That's fine. No errors, and we're calling it. Let's try it. Do I still have myself at 1 frame per second? I do. This is going to be a little bit too slow. Let's bring ourselves back up to 10 frames per second, and let's maybe make like 100 of these. And that should help us like actually see what's going on here. Ooh, I think I saw them bouncing off of each other. Here, like this one is bouncing like back and forth. Although some of them are just sort of like vibrating in place, which is not ideal. So close. Now they're all sort of stuck there. turn them a little bit instead of reversing. Ooh, yeah, that might be good. Turn them a little bit, and then the other problem is like there's a few of them that are still like have their freedom. The rest of them are all just sort of stuck with each other. These ones are like constantly changing which cells they're in. That's fun. I mean, technically it's working. For every cell we're checking each other. Here, this one's about to get. Oh, interesting. It's almost like they knock each other free when they hit. And that's pretty cool. You can adjust based upon the position of other, so it's this one. If it's okay, let's do that. Let's come into unit here. In a handle collision, let's not do this entire 1/2 thing. I don't think this is helpful. You can adjust based upon a position of other, so if it's less than this one in an axis, it'll turn away. Let's see if I fully understand here. We have my location, we have the other location, we have access to the direction, so we can know if they're like where they are, the X and Y compared to each other. Oh, so if like the X's are the same, if like one's the X is to the right but the Y is greater than, we have this Y like start going down more. And then I also need to set it farther away from itself to like actually jump a little bit, so they don't freeze on each other, which I think is what's happening here. So we figure out our distance. We subtract the radius. Okay, so if our distance is less than that, so if we're impacting with this, we don't want to just blindly reverse our velocities. Instead, and this might be another whiteboard here. All right, let's try this again. If I have a circle here and a circle here, and they're just touching, I want this one to go down this direction maybe, and this one to move up in that direction. But what their x's can remain the same. So like if this guy was moving to the right, it will now actually be, I probably want to stop their x's, and like then they could just move off in the, what is it, cardinal directions, is that what it is? Where it's like, then I'm gonna just move like up, down, left, right. That doesn't seem right. I want them to be able to move at angles still. I actually want, like, see, if your direction is something like, well, okay, if you're moving exactly at each other, I want you to reverse, and at the end of it, you're going away from each other. If these over here, if you were heading up like that, and you're heading down like this, and you just happen to collide with each other, I want you to essentially be going, you're going in the opposite direction of each other every time, but you should be you shouldn't be like a pure bounce. And I wonder exactly what the mathematical equation for this is. I often don't like look up what those are in Wikipedia. I often like try to figure this out on my own, but it does make it like interesting. Because I often like spend more time thinking about this than I probably need to. So if we're heading in this one, we impact, I need to move like my x slightly away, the x will be minused a little bit and the y will be increased or subtracted, I guess, because it's going upwards now. Am I thinking about that correctly? What is that link, Verduda? Basically, turn away the nearest. Okay, let's. Oh, I see. Okay. Light shot. I don't think I've used light shot before. Oh, no, that's the wrong. There you go. I can't make it bigger? That's cool. It would be nice if this lets me like make it bigger and fills out the screen, but I guess not. So our X, so the one of the circles is coming down, it's gonna turn away. You can control plus. Oh, okay, I could just make it bigger that way. So let's see. We're turning away the Y, and this is turning away the X. You would increase the X velocity and increase the Y velocity, reducing the Y for this one and increasing the X for this one. I guess like one of them gets the X and one of them gets the Y. Is that, am I like correct in thinking that that's how it's going to be? So I want, if the object continues to get closer, it would mathematically shift towards tuning more to Y. Or should it be if I am above the other unit? If I'm above the other unit, I want to decrease my Y. So like I turn back away. And if I'm below, I do my X. Is that how? So like if self.x is, let's see, do self.y. If that is less than, so this is above, if it's less than or equal to other.y, you're not concrete on the math for two velocities. Neither am I. Okay, so let's just try it. Let's just see what it looks like. So self.y equals the other.y here. I'm above them. Is if I'm here, I'm above them. I want to now turn my y and increase my velocity. So I want to now do self.velocity y minus equals to like, I don't know, 0.3. I don't know if that number is good. I'm just like throwing it out. You have to translate how that would work from an angle plus velocity is two velocities. Yeah, angular momentum is not something I've like looked into a lot recently. That's like basically back in high school days. Now, otherwise, else if self dot, if I'm greater than self dot y, okay. So we're nowhere connecting. So like we could just do maybe an else here. If I do self dot velocity x plus equals to 0.3, is that right? Or do I want to do this as a else self dot velocity y plus equals to 0.3 if self.x is less than or equal to other.x, self.velocity x minus equals 0.3, else self dot velocity x plus equals to 0.3. No idea what this is going to do. This is, by the way, one of the funnest things that I have about playing with graphical stuff like this. We could see the reactions immediately. So we're just going to affect ourselves with this. And I think that's going to be fine. Then I want to just run it. Let's just try it. I mean, they gain speed, which is maybe not like fully ideal, but it like looks good now. Although sometimes, yeah, they're gaining a little bit too much speed. So we need to avoid the acceleration. And I wonder, I could normalize it. So if I normalize their velocities, then I could multiply it by whatever speed I want them to go. And that would like have them, you know, not potentially go over each other because they're moving too fast. I think that would work. And then I can also like bring this back in. So is it plus self dot radii? Let's actually just multiply by its 2. So times 2.0. Now they're going to do this collision if they're within 2 of each other. So they're trying to avoid each other. But they're getting really fast when they try to avoid each other. Okay, so I don't want to like just do this blindly. I want to adjust their velocities. But then I want to, at the end, reset them. So I can normalize them, then multiply. So after doing this, we could do a, what would this be? It would be a vector2 new self dot velocity x, self dot velocity y dot normalize. And then I want to multiply this by whatever speed that we want it to be. So something like 1.0. Seems silly to do that. So then this is going to be like the new speed. So that new speed or new velocity equals, and then we'll do self dot velocity x equals new velocity dot x. Self dot velocity y equals new velocity dot y. Okay. All right. Cargo run. See if they now don't increase their speed too much. Ooh, I don't think they do. I think everything is sort of now moving the way we want them to. Ooh, I like it. Now, the best thing that I could do is calculate like the angle that they're coming in at and like then affect that angle going out. That may be a little bit beyond like what I have right now, but they're definitely trying to like avoid each other, which is really, really kind of awesome. If I were to try to make it so that they moved in the same direction as each other, so if I adjusted their velocities toward each other, so if I say self.velocity y, I want to match the other velocity. Do I want to match it, or do I want to like subtract it or something else like that? Fair dude, I like you're trying to give Chantilly hints about what you did. Let's set the velocity equal to the other dot velocity y. And then let's just try setting it equal. If I'm on one side, yeah, let's just go with, what if I just do this? I wonder what this will do. Equals other dot velocity x. Hey, look at that. They're now sort of kind of moving in the same direction as each other. Like as soon as they come within a certain amount, they're now moving together. So it's kind of flocking. They kind of like get overridden with each other, and they're also not bouncing off the walls anymore, which that's a little bit unfortunate. But we kind of got these like groups of them moving with each other, which is actually really cool. The gentler turn instead of the reverse should naturally make them flock to some extent over time. Yeah, we can definitely see like a flocking behavior happening. It's not the right full like flocking behavior. And they can overwrite, like they can just sort of sit on top of each other, which is less, less good. But yeah, it's kind of working. They're kind of getting stuck on the edges. But then again, then one of them moves and decides to leave, and they're all following in a line, which is kind of fun. The wall bounce is definitely breaking it. But I think that what we have here is a good example of like what I wanted to show off, which is every of one of these cells, it's doing the detection with each other independently. So like, for example, this one isn't detecting any of those. It's only detecting ones in the same cell as it. Which I think is actually really awesome, because that means I can have a lot more of these, and they won't try, like this dot over here won't see if it's next to this dot over here. It just won't ever happen. Which is really nice, which means I can now increase the number of these that I have. Let's go back up to 500 and see what happens. And let's actually also increase our frames per second back to normal. Basically, no real drop in like what we can do frames per second. It's still no. Okay, never mind. Now it's having a little bit of troubles. Because everything is moving into the same cells. And so now like all of the points about having a grid system is just being completely ignored. Oh, that actually froze the game. That's cool. So there's some problems here. Chantilly, do you want me to tell you what I think Bear Doodad is doing? Oh, Bear Potato, you're being more explicit. All right, so this is less cool. I fully crashed. All right. So too many go into the cell. At that point in time, if I want to do something exactly like that, I need to move away from just a grid system like this and move on to like a different type of a spatial proximity system. More like what is it? Quad. There's the quad. I forget what it's called. The quad something, where you like break everything into like quads, and then break those into quads and break those into quads until there's a certain number of elements maximum inside quad tree. That's what it is. Also, good morning, Alka. Although I know for you it's not morning, but welcome. So I think we're mostly good here. It does crash because of the entire, like, you know, everything like banging into each other. Barely the afternoon. Okay. Or is it like too late? Because I think you're in Europe, right? Or am I thinking about something else? Somebody else. For our unit, let's actually take off the following each other thing. Oh, you're in Houston. Okay. Then yeah, okay, that's only an hour after me. In that case, happy midday. When they come up here, let's just have them turn away from each other and not try to follow each other anymore. I think we can undo. There. Do this again. They don't care about each other anymore. They're just gonna like turn. I can actually do this as like a negative self.01. Save you. We normalize, we do all that stuff. Let's go ahead and try running this with our 500. And now they're sort of all moving against each other. They're trying to bounce, but oh no. They try to go back up, but they end up bouncing against each other and they just all end up down to the bottom. So exactly the same problem ends up happening, which is less than ideal. So I need to figure out what my appropriate like turning is in order for them to like be everywhere all at the same time. This is less than ideal. I think it's showing off what I wanted to show off. It's just not quite what we want it to be. If I just have this reverse themselves, they also get into those like, let's see. What if I just reverse their velocities? Times equals negative 1.0. This is gonna be my last experiment before I call this entire thing done and good. It's so fun to like go through and just play with all these numbers and just see what happens. Okay, now they're not like all going down to the bottom, it looks like. And they're sort of like bouncing off of each other, which is kind of nice to see. They got some weird interactions, but I think that's fine. I'm gonna go ahead and call this chapter closed and good. Yeah, done, good, and ship it. Exactly. I don't remember. Did I create a? No, I didn't create a. I have like some ideas that I want to create for like the emoji, and I tried to create some of them, but like it kept on failing when I was uploading them. So it's I don't have them yet, but I'm